In today's video, we'll be learning about indefinite integrals with simple polynomial functions. Again, indefinite integrals with polynomial functions. So, to start off, this is an indefinite integral, right? And it's just an S with no type of bound, such as 0 to 4. It's just a big S. We'll learn more about indefinite integrals later, in later videos I'll make. So, indefinite integrals, for them, right, we'll have, let's just make an example here. Yeah, a good example. And then we need to have dx here. So this is how you should write an indefinite integral. Now, how do you solve them? Well, for example, if you have n times x to the y power, well, in order to solve this, right, we'd have to add 1 to the y power and divide by 1 at y plus 1, and that would be your answer right here. Now let's apply that to integral here. So if we do 4 times x to the 2 plus 1 power over 2 plus 1, and then if we do 1 plus 1, remember just adding 1 to the exponent and then you divide by 1 plus 1, you get 4 over 3 times x to the third power. And here you get 2 times x to the second power. And now you would actually have to add something else, and it's called the constant of integration. Now this C is very important, okay? For every indefinite integral, I repeat, for every indefinite integral, indefinite, you have to add this plus C here. Okay? Now let's do some more examples. Alright. Alright. So these are the equations, or the integrals, indefinite integrals to solve. Pause the video. When you're done, click to see if you got them all correct. Alright, here's how you solve them. First off, for the first one, 1 plus 1, right? So we do 1 plus 1 over 1 plus 1. And then plus, well, what is the integral of 1? Well, 1, right, times x to the 0 power. In order to solve this, we have to add 1 to here, to the 0 here. So this becomes 1 plus times 0 plus 1 over 0 plus 1. And then here you just get x to the 1 power over 1, and this is just x. So our answer is just x plus c. Remember, always remember the plus c. And then you can actually simplify this equation even more by replacing this, right, with just x squared. Since, alright, let me write that again. Since 2 divided by 2 is just 1, and then 1 plus 1 is just x squared. So it's just this. That's the correct answer. Okay. Now time for this problem here. So 4, this becomes there, and then divide by 5 plus 1. Same thing here. 4 plus 1, and divide by everything by 4 plus 1, plus c. Right, and then this becomes 2/3, since 4 divided by 6 can be simplified to 2/3. And that's your answer right there. And again, you do the same thing here. 4 over 5 plus times x to the 5th power and plus c. That's your answer right here. Okay, last problem. So if we do 2 plus 1 over 2 plus 1, and then here if you do 3 plus 1, right? 3 plus 1 over 3 plus 1, we get 3 not 3, my bad. 2 I meant, right? Because I made a mistake there. 6 divided by 3 is actually 2. So yeah, 2 times x to the 3rd power plus 4 over 4, which is then just 1. So then we have to write that again. And then let's do the 4th power, because 3 plus 1 is just 4. So this is our answer right here. Now we can actually verify that these are all correct. How? Well, let's start off with the first equation, with the first integral up top. Now, if you're to take the integral up top, right, it would be 2 times 1, and then 2 minus 1, which would just give you 2x, plus x, right? That the derivative of x is just 1, so you would get 2x plus 1 plus 0, and then the answer would just be 2x plus 1, since the derivative of any constant is just 0. And that's actually not a coincidence, right? Because when you derive the answer of an integral, if you get the integral you were trying to solve before, you got the integral correct, and that's just a proven fact. So, and if you were to do it on any of these answers here on the right, you would see that they're all correct, since you'd get the same answer from the derivative. Here, here, here. You get all these answers if you derived on the integrals on the right side. The answers from the integrals on the right side. Okay. Now, there's one last thing I'd like to reiterate, right? And that would be the integral of constants. The integral of constants is easier than you think, right? So for example, if you have this, let's put 100x for no reason. 100x, yeah, okay. So, right, and then we'll have the integral of constants on the side here. So these integrals here, right, these are pretty self-explanatory, right? You just have to add 1 to the exponent and then divide by 2 for all of them, since 1 plus 1 is equal to 2. However, for these integrals here, they're not that self-explanatory, because you kind of have to notice, like, rewrite this 7 as 7 times x to the 0 power in order to write it as then 7x plus constant. However, there's actually a trick to this. And whenever you see the integral of a constant, just remember, all you have to do is if you see the integral of a constant, all you have to do is write the constant, an x value, and then plus c. Same thing for 8. Constant, put the x beside the 8 plus c. And if you were to take the integral, right, of 7 like this, the old-fashioned way, and just actually like write x like this, and then you just add plus 1, and then 0, and then this, it gives you 7x plus c. You'd see that the way of just adding x plus x and then plus c works, according to this proven theorem right here. So yeah, that's just a shortcut for constants. Okay. Those were indefinite integrals with polynomial expressions, and I'll see you in the next video.